A very good morning to Sezurhana and my fellow friends. So I am Priti Zinta from Math 3825. Today I'll be presenting application of vector concept in hemodynamics. Today we'll be understanding blood flow using vector flow imaging. So this is all of our contents today from 1.0 to 6.0. First of all, for introduction, I would like to say that vector can be described as something having quantities and direction. For example, blood flow in the human body, which studied in hemodynamics, since blood moves with both speed and direction through vessel, it is considered a vector quantity, and its behavior is analyzed using physical principle of circulation. So we can see the behavior of blood flow on the image we have on the slide for normal artery and artery with stenosis that we will go through together later in the slide. 2.0 Hemodynamics as a field involving vector. Hemodynamics is a branch of physiology that focuses on how blood moves through the cardiovascular system involving heart, arteries, and veins. It examines the relationship between blood flow, pressure, resistance, and the structure of blood vessel itself. In this system, blood flow described using velocity, which has both magnitude and direction. Each movement of blood within a vessel can be represented as a velocity vector, helping researcher and clinician analyze flow patterns and the effects of vessels diameter on circulation. So we can see here artery with stenosis are having vertical velocity at centimeter per second due to the disturbance, and the horizontal blood flow velocity is 15 centimeter per second for a normal blood flow lah, without any disturbance. In modern imaging techniques, we have VFI, vector flow imaging. Apply this vector concept to provide more detailed insight. VFI capture velocity in multiple directions and produce angle-independent, detailed flow maps, allowing for a clearer understanding of complex blood flow. As VFI producing a very detailed pictures. For example, we can see in the middle of our slide, we can understand even the direction or the patterns of blood flow are very complicated because it is producing a very detailed picture. We can see what is the behavior of the blood flows in our blood vessels. Compared to traditional Doppler ultrasound, which is only measure flow along the ultrasound beam. Like we can see the produced picture in the slide 2. For arterial stenosis, we can see it in 3.0 as a real-life problem involving blood flow. It is happening when arteries narrowed due to plaque build up along its wall. As the vessel becomes tighter, blood velocity increases and the flow may turn irregular or even turbulent. It's raising the risk of serious conditions such as heart attacks and stroke, or even more dangerous, it may cause death. Vector flow imaging VFI offer a more complete solution by measuring both the magnitude and directions of blood velocity at the same time. Doctors can clearly observe complex patterns such as swirling, flow separation, and turbulence in narrowed vessel. As noted by Koo 1997, this vector-based approach improved the detection of abnormal flow and enhanced the accuracy of cardiovascular diagnosis. We can see the example of our blood vessel having this arterial stenosis in the slide. For 4.0, example of vector calculation in blood flow, we can continue the real-life problem just now. We can study where plaques narrows an artery and disrupt normal circulations. Using concept applied in VFI, blood velocity can be resolved into vector component, horizontal velocity and vertical velocity. So we can consider that W is our horizontal velocity along the vessel. So it is 15I equal to 15 cm per second, and our R is vertical velocity equal to 8J equal to 8 cm per second with disturbance due to stenosis. We can see on the picture also. For calculation, in order to find V, we can use our vector calculation that we have learned in our kuliah, in our lecture. To find V, we can add W and R. And so here we just need to add up 15I plus 8J. But in order to find resultant velocity V, we need to use square root 15 square plus 8 square, and then we will find 17 centimeter per second. And then to find the direction of the blood flow due to the disturbance, we can use the technique of Sohcatwa, and we just use reverse tangent vertical velocity over horizontal velocity, and then we will have 28 degrees for the angle. This means the blood flow is no longer flowing straight but deviating at angle 28 degrees, and it's having resultant velocity 17 cm per second as the vessel narrowing. In VFI, it visualized in abnormal direction, showing disturbed flow patterns. This finding help doctors detect the abnormalities like stenosis, as normal blood flow should have minimal vertical component, which is 0 or nearly to 0, as it should go straight. We can see on the image provided the vertical velocity, the horizontal velocity, and the angle of direction with the resultant velocity due to the disturbance. So here is 5.0, importance of vector analysis in medical diagnosis. First of all, it enables detection of abnormalities in blood flow. Next, identify issues as turbulence, reverse flow, and unusually high velocity. Supports more precise diagnosis of cardiovascular disease. Improve monitoring of patients' condition over time. It is also represents blood flow as velocity vector which involve magnitude and direction, giving a clearer understanding of circulation. It helps indicate medical condition like narrowed arteries or faulty heart valve. So it offers greater accuracy compared to traditional Doppler ultrasound method. So amongst all of this, it helps enhance treatment planning for better medical outcomes. In conclusion, vectors are important mathematical tools used to describe quantities that have both magnitude and direction. Blood flow in the cardiovascular system is clear example for a vector quantity because it involves both speed and direction as blood travels through vessels. The field of hemodynamics uses vector analysis to study circulation and understand how blood moves within the body. Technologies such as vector flow imaging apply vector principle to visualize complex blood flow patterns and detect abnormalities. Therefore, the application of vector in hemodynamics demonstrates how mathematical concepts can play a significant role in improving medical diagnosis and understanding human health. So here is our reference that I used to do these findings. So this is all from me. Thank you.